Well, hello and welcome to this exercise of the transformation of an inverse function or graph by stretch. It's an iGCSE, GCSE high school algebra, and it says here is a sketch graph of y is equal to a function of x, and then it says uh, the graph passes through the point with coordinates 0, minus a half, and has two asymptotes of x equal to 2 and y is equal to 0. And then it says in the space opposite, and I'm going to cheat here. I'm not going to sketch it by hand. I'm going to use my graphing calculator because I haven't got the facility to do sketching by hand, okay, or sketching manually. So in the space opposite, sketch the graph of y is equal to f of half x, and then it goes on to say state the equations of the asymptotes of this curve and show the coordinates of any point where the graph of y is equal to f of half x intersects the axes. Okay, now I'm going to create some space for myself and I'm going to move to the next slide. Okay, now for this slide, all I've done here is to reproduce, the original question. Okay, so that's what it got there. There are a few things to note here. Firstly, for this graph given to us here, this point there is 0 minus a half. Okay, and we want to find, and we're given the asymptotes of x equal to 2 and y is equal to 0. Now these are very important when we come to sketch the graph of function of f is equal function of half x there. So this line is the equation for the asymptote of the vertical asymptote at x equal to 2. And the horizontal asymptote, as we are given, is y is equal to 0 or the x-axis. Okay. Now I'm going to be very deliberate. I know it sounds silly, but I'm sure you can do this in less than 3 minutes. But I'm going to take my time to try and explain what I'm doing here. Now what I've done is I've got a cluster of graphs here. Okay. I know I'm cheating. I'm using my graphing calculator to do this. Now, for the brown graph, that is a graph of g of x is equal to 1 over x. There are two parts, that one because an inverse function, that one there. So that's the graph of g of x is equal to 1 over x there. Okay. And for this graph of g of x, the asymptote is the y-axis or the line x is equal to 0. As a vertical asymptote. Now the horizontal asymptote is y is equal to 0, which is the x-axis. Okay. Now for this graph, this one here, which I've reproduced here in blue. Now note that the asymptote for the default function, which is g of x, the asymptote has been moved 2 units to the right. Okay. So now we are now in a position to define this graph by its equation, and the equation is f of x equal to g of x minus 2. So we now effectively replace x there in the parent function, replace x with x minus 2. So we then have that f of x is equal to 1 over x minus 2. So this graph given to us in the original question is a graph of y is equal to 1 over x minus 2. Okay. Right. Now we are required to sketch the graph of f of x over 2 there. So in effect, we need to replace this x here with 0.5x or half x. So we're looking for this. We want to sketch this graph. Now, note here that the horizontal axis will not change. It will still be the line on the x-axis, or y is equal to 0. So that does not change. One of the questions is to state the equations of the asymptotes. So that's y is equal to 0. We now need to find the equation of the vertical asymptote. Now, to do that, we know that we are not allowed, or having 0 as the denominator in this fraction, as it were, that will not be valid. So we're looking for a critical point such that the value of x will give us 0 there. And if we then equate 0.5x minus 2 is equal to 0, you will end up with x is equal to 4, which means that x cannot be equal to 4. So our vertical asymptote then becomes x is equal to 4, and our horizontal asymptote will be y is equal to 0. So this graph here is a graph of the graph of y is equal to 1 over 0.5x minus 2. And these two graphs are, these two curves, this one and that one, are part of the same graphs for the same function there. So vertical asymptote is at x is equal to 4 there. So what we now have is transformation of f of x is equal to 1 over x minus 2 to 1 over 0.5x minus 2. So that's the transformation from this graph in blue to the graph in black there. And also note here that if x is 0, y is a half. So in effect, the other question we ask is, at what point do they cross the axis? Now, this is one of the points, 0 and 0 and minus 0.5. So that point is invariant. It does not move after transformation. So now, what we then have, if you take the original graph, if you say this is the original graph given to us there, for a given y coordinate, the x coordinate in the transformed graph is doubled, because at this point x is 4 in the original graph given to us in the question. Now after transformation, the y coordinate has got an equivalent x coordinate of 8. So that point there is a half 8. Whereas this point here is a half 4. So after transformation, a half 4 now becomes a half 8. So we then say that the graph of f of x equal to 1 over x minus 2 has been transformed to the graph of f of 0.5x by a stretch factor of 2 parallel to the x-axis. Now, I know this has been deliberate, but I hope all that made some sense, and please subscribe. Thank you for watching, and bye-bye now.